Possibly involve the EGL part. So we have the HTML5 documentation here. Now there's a UI component which might, we get an Emscripten event resize. Which I guess we can use. So when we get a resize, we get the UI callback function. Now the UI callback function gives us an Emscripten UI event structure. So Emscripten UI event has some detail, a document body, some width of the browser window, which is not really that relevant. We want the size of the canvas, if anything. So that might be a little bit more annoying. Do we have any way to get so Emscripten has some information about there. That's an interesting one. EM canvas resize callback function. So that is one thing we really want. So this points to a user provided callback function which will be created whenever blah blah blah. So I want to know how I set that. Okay, so it's a full screen strategy. So this has something to do with the full screen mode, I'm guessing. Full screen defines various things. It has the full screen event, it has the full screen strategy, it has some callback functions. Here we go. Set full screen, change false back, request full screen strategy, exit full screen, enter soft full screen, exit soft full screen. I'm getting to the point where I'm wondering if this is like just a variable that I write to, and that's it. Which seems awfully simple. I'm concerned. I'm gonna operate on that this is just like a function that I set, and then we see what happens. So we're gonna switch back here. Now, size of the window, I believe, is in the renderer. Yeah, we set a GL viewport here. Which is all fine and dandy. So what we need to do is we need to have our renderer. It is going to know the width and height here. These are unused at the moment. We are just going to quickly initialize them to something not entirely insane. 100 by 100. So we're then going to set up our GL viewport based on these. Now we also need to touch the camera because the camera sets up a perspective transform here, which has an idea of the aspect ratio. I'm just going to note here, view, update aspect ratio, and see if I can't spell that correctly because we need to come back to that in a bit. Now, we have our camera being passed in here, which means we don't actually know what the camera is. Now the question is, I think the way we do this is that we, on both the GLES renderer and on the camera, we update with viewport resize methods. So here, we're going to have a void, and it's going to be called viewport resize, and we're going to pass it in the new width and height. And we're going to do the same for our camera class here. Now for the GLES renderer here, we can quickly implement that because that is GLES renderer viewport resize. We simply set this, our internal width, to the width and the height. That way our GL viewport will get updated and we should be good to go. That is all that's needed there. Now for the camera, it's somewhat similar. What we need to do here for our camera, when the viewport resizes, is that we need to set up a new projection transform, and we need to do our aspect ratio, which is width divided by height. Now this is a little bit annoying because these are integers. We need to do this in floating point math, so we're just gonna convert these to floats. So that way we should get our projection transform set up based on this new viewport. So what we're going to do is we're going to go for our main function here. We have a main loop, and various other things. What we're going to do is we are going to introduce a resize. Just going to head back over here because I need to find that resize stuff again. Okay, so it's part of the full screen strategy. Interesting. So that's done by going for the request a given target element to transition to full screen mode using a custom presentation mode for the element. But I'm not interested in going full screen, I just want to pick up resizes. Okay, resize on this page. Resizes. Yeah, I can set the resize of various things. So set resize, set scroll callback. Event specification only requires that the window object sends resize events. It is valid to register a resize callback for other DOM elements, but the browser is not required to fire these events. So we can't really use that. Lots of stuff about full screen. Full screen again, full screen again, full screen. Resizes the CSS width and height of the element. Now the interesting thing is I can get the element CSS size, which is interesting enough because we're going to need to get the element size of the canvas. So what we're going to do, that was not what I wanted to do. So we have this get element CSS size. Do I have anything interesting on the canvas? So if I set the target to 0, the element specified by module the canvas will be used, so it by default uses the canvas. So that's great. That's the mouse event. So there's an Emscripten set canvas size. Oh, so this is the, oh, I'm starting to understand a couple of things now. So there's like the HTML5 is like low-level HTML5. Emscripten is sort of also interfaces with the wrapper around it. So this might be where we want to find our stuff. Because there's definitely sort of, now I decided to browse away from it, set size, set canvas size, there we go. Because it resizes the pixel width and height of the canvas element on the Emscripten webpage. I'm pretty sure that sets like the width and height attributes on the tag, which is one thing we're going to want to do when we have a resize event. We need to say, well, okay, what's the size of the canvas now? And then set both those tags and update our camera and renderer for that. Now the trick is still getting that. Anyways, so what we can do is we can at least do Emscripten get canvas size. Because what we need to do when we first set up and we create our renderer and camera, we need to set an initial size of that. So what we're going to do, I'm just going to create a block here, is I'm going to pull in, okay, these are integers, int width and height. And it also needs an is full screen, which we're not going to use right now. Just to be consistent in naming, that's going to be is full screen. So what we can do is we can call Emscripten Emscripten. Oh my god, I am not typing well today. Canvas size. And I'd like to store that in width, in height, and in is full screen. So we grab those, then we're going to call our renderer and ask it to do a, what's it called? Viewport resize. So we're going to do a viewport resize based on the width and the height. Panda, I might be generating new names for characters at this point. Friends for Chuck. And this is one of those places where I decide to copy paste and then C-Line decides to barf on me. Occasionally it does that. Just one moment. We'll have to kill it and start it up again. Wonderful stuff. Let's see if I can even find C-Line so that I can even kill it. There is. Let's see how much code we just lost. Hopefully not too much. Only all of it here. So that's good. Anyways, so we needed integers width, height, and is full screen. Then we call Emscripten get canvas size, pass it the width, height, and is full screen, like that. Then renderer, viewport, and I can't remember if it was changed or resized, viewport resize. The viewport resize based on the width and the height, like that. And then we're going to do the same for the camera. And hopefully that compiles. Well, it seems to. Yep, it compiles. So we're just going to switch over here. And we're going to try and reload. So something at least happened. I actually have no idea what size we're rendering at right now. We should probably also... Yeah, that just grabs those sizes, so that's great. What we actually probably should do at this point when we start up is, rather than grab the sort of the width and height of the tag, we should probably grab the size of the element. So that was like way down at the bottom here. Get element CSS size, and then also set that. So that way we're at least getting the first one right. So let's just switch over here. So what we should actually be doing... Oh, and these are doubles? That makes life interesting. But I guess they can be. Yeah, we're just going to truncate them and pretend like that's not a thing. But it is totally a thing. And it sucks. So we're going to get element CSS size. And if we just pass it nothing, it will take the canvas. Because that's the default for this thing. We store that in width. And we store that in height. Now, rather than going for the get canvas, we go set canvas size. And I hope that might be the signature. And take integer from a pointer, which is not what we want. We want to do that. And values of type double may not fit into the receiver type int, but that's just life sometimes. So let's link that. And we're going to try and see what happens over here. Hopefully it won't be as ugly as it is right now. So now we get a nice matching render size, at least as far as I can tell. Yeah, it looks like we can see the individual pixels here. It's not scaling. Of course, we can just quickly turn on. We can't actually open the inspector because that will change the scale of stuff, so that's a bad idea. So now we need to pick up on resizing. So there was something about resizing a window. I vaguely remember. Yeah, you can set a resize callback, which will be called whenever the window resizes. But I'm going to assume that people don't mess around with the CSS, and if they do, well, we can technically attach it to both the window and to the canvas element, because that way we will get a resize event on both of them, and then we'll just do the same thing on both of them. So for browsers that actually give us resize events on individual elements, it'll work if you sort of do weird stuff with the code, and otherwise we'll just do a best effort based on the window. So what we're going to do, and this is the MUI callback function. So what we want to do is we're going to have a mBool. We return a Boolean. Now I can't remember whether we should return true or false from these generally, but I'm assuming that in our input we do these every once in a while, we return true. And I think that's because we've handled the event and it should not propagate further. Basically, I can't remember HTML event propagation. It's a horrible mess. Anyways, we're going to call this on resize. So what we get here is, there we go, we get an integer, which is the event type. we get a constant Emscripten UI event pointer, which is the UI event. And we get a void pointer of user data, which we're not really going to be interested in. So in this case, what happens is we've got our UI event. I don't really have much to do. We're just going to go through all of this code again. In fact, it's not going to do anything different. So in fact, we're just going to call this method here with dummy data. And here we want to return the Emscripten true. There we go. Now we also want to register this for resizes. So Emscripten Emscripten set resize callback. So first one is on the window. We're not going to have any user data. I would like to use capture, yes. And the callback is going to be on resize. There we go. I believe that's also how we set it up for the input. Yeah, we also use capture. And then we're going to do the same on the canvas element. Canvas, like so. Because there should be a description here at the top. Yeah, hashtag window gives us event listeners on window. Hashtag canvas gives us to the Emscripten default WebGL canvas element, which is what we want. So compile. Switch back over here. Reload. And with any luck, if we open the inspector here, now we didn't get a window resize event here, so the canvas hasn't updated surprisingly enough, or not really surprisingly. At least I don't think so. So I'm just going to reload again here. Now there's an interesting thing I'm noticing here is that it's going for that the height of this is 617, which is kind of right because that is the width of the main area here and the padding below it. But I'd really not like to have the padding included in that because that does mean that we get scaling on one axis. It would be really nice to avoid that. So we can either hard code this, which I'm not really a fan of. We might also consider changing our layout a little bit. Possibly what might be worth doing is actually making the background of this log here transparent. And then we're just gonna go for having the text on top of it and actually filling the entire screen with the game, which I think is probably the better option. So that means we're going to go back into the HTML. So our canvas is no longer has a bottom here, so we don't need the box sizing either. It's just full screen or full window. And our output at the bottom is not background color black. It is going to be RGBA 0, 0, 0, and then 1.7. I think 1.7 is a good number. Let's see how that looks. So now we actually have stuff going through here. And if I resize this, then the canvas also gets resized and our render changes as well. So it's actually working, which is nice. So we now have a nice big view of everything going on, and a nice little log at the bottom. So I think this is in a state where I'm willing to put that on the web. That didn't take too long. So I think we're going to manage to do another little thing today. And the thing I want to do, you'll notice that sort of the terrain is generating in a not really intelligent way. It's sort of starting with the blocks furthest away and then moving closer. I'd like to change it so that it starts close and then moves further away. And I think that should be doable. So let's just take a look at what's going on when we do this. That is in our world, I believe. So what we're doing is we have a list of render chunks, which are the chunks we want to render. We put that in an unordered set, and then we walk through them. So when we're doing render chunks, we look up and count them, and then we erase them from this list. So that makes it actually a little bit difficult because we want this to have the fast lookup for this. I was kind of hoping that we could just order this list in a specific way, but unfortunately not. So what we should do in a sense is then when we're missing a chunk, we should walk through all the chunks that we have and then pick the one that has the lowest coordinates, essentially. So what we're gonna do is we are gonna walk through this, and we're gonna do something sneaky here. So we have at least one render chunk, so we know we'll be passing through this stuff at least once. So a render chunk is a GLMI vector 3. So we start with a chunk position, which is just going to be nothing here. And then do we have the center at this point? We should have, yeah, we have the center as an absolute position, which gives us a chunk center and so on. So what I want to do is I want to say that we're just going to do this integer. It doesn't have to be nicely precise. It doesn't have to be a cool circle around here in like Euclidean. We're going to work on something called Manhattan distance here, which is a lot easier. So what I want to do is I want to do an integer distance, which is the distance of the current chunk. And we are going to start this thing as numeric limit of int. So it's going to start as the biggest integer you can ever imagine. Sort of. So what we're going to do here is that we are going to go for every position in our render chunks, so the chunks we wish to have rendered, what we are going to do is we're going to calculate a candidate distance. So this candidate distance is going to be the absolute value, standard abs, of, and at this point I might need to include some math. So include CMath. What we're going to do is we are going to take basically this. So the difference between this chunk position and our center position. And then we're going to add for the other two axes. So for Y and for Z as well. And then if this distance is closer than the distance we have so far, we're gonna first of all store that this is the closest we've seen so far, and we are gonna save this position as the position we want to generate. So let's rebuild that. Does a little bit of linking, and we can switch over. and reload. And now you'll see that we're actually generating the closer chunks first. At least to some degree. So this does not look quite right. That's because it's plus here, which is not what I want. I want minus. I want to go for the one that has the lowest difference. That will make a massive difference in the direction, because now we were just starting with the ones near 0 and then working away from there. And oh, I've managed to switch build targets. I want to build long shot. There we go. Let's switch back and reload. And then hopefully as I move away here, it should prioritize chunks that are close to me. So that should make it rather difficult to sort of escape. And it looks like it's working. Let's just try and climb this little mountain here. I'm really happy with this. It looks nice. I, however, think that's where we're going to call it today. It's going to be a little bit of a short stream, but I've had a long trip and I'm really tired at this point. So that's it for today. Next week, I suspect that we will be looking at texturing again. Specifically, we're going to look at loading in multiple textures and actually having multiple different blocks in the world so that we can maybe escape all of this grayness. Maybe add a little bit of green, maybe some other stuff. That's sort of my preliminary plan. We might also start looking at adding sort of entities and stuff to the world. Perhaps. And yeah, once again, WebGL context lost. I should probably have a look at whether or not there's an issue with my graphics card, because it seems to be stalling a lot. But yeah, that's the plan for next week. For now, thank you to everyone who tuned in, and have a great continued evening. Bye!